So a combination is just sort of think about it as a group of objects. They're not arranged. The order doesn't matter. You're just selecting a group. And so what you want to think about is that if you know how many ways there are to arrange a particular number of objects, then to find out how many ways there are to just select a group of them, you divide by r factorial. And the reason you do that is this undoes the arranging part. So the number of combinations of R objects chosen from a collection of n total objects is C n comma r, which is just P of n comma r divided by r factorial. Or remember P was n factorial over n minus r factorial, and then put that r factorial in the denominator to get rid of the arrangements part. This is another example you can use Desmos to find that number. But if you think about it, if you have 4 letters and you're choosing a group of 3, so let's say we have the letters A, B, C, and D. If I choose the letters A, B, C in that order, and I choose the letters C, B, A in this order, these are the same groups. So there should be fewer groups of objects than there are arrangements of objects. So the ones I have are A, B, C, A, B, D, A, C, D, and B, C, D. There are just 4 combinations or unordered sets.
I didn't get that. Could you try again?
So let's try to think about the differences between permutations and combinations. In a permutation, order matters. And in a combination, it doesn't. When you think about a permutation, you want to think about an arrangement or a lineup or an ordered set of prizes or places or finishing order. When you think about a combination, you're going to think about just like a group of friends or a collection of items or an unordered set. So when you read a problem first, I want you to sort of think about, should it be a permutation, should it be a combination? The Classical Studies Department has 7 faculty members. 3 must attend the graduation ceremonies. How many different groups of 3 can be chosen? So we don't care which order they attend in. They're not going to line them up in a particular order. They're all just going to be sitting in random seats. So this is a combination because the order doesn't matter. They just have to go. So C of 7 comma 3. So that's going to be 7 factorial over 7 minus 3 factorial times 3 factorial. 7 factorial over 4 factorial times 3 factorial. Again, you can just put this in Desmos. Same place. You go to functions and you scroll down to NCR. We have 7 objects and we're choosing 3 of them to put in a group. 35 total possibilities. 35 different groups. A team of 8 students goes on an excursion in 2 cars, of which one can accommodate 5 and the other only 4. how many ways can they travel? So if I have 8 students and I have 2 cars, this car over here can hold up to 5, and this car over here can hold up to 4. So if I think about what I can do, I can break them into a group with 4 and 4, or I can break them into a group with 5 and 3, right? So 4 and 4, or 5 and 3. So to break them into a group of 4 and 4, I'm going to take the 8 students and I'm going to choose 4 of them. And then there's only 4 left, and I have to choose all 4 of those to go in the other car. Or, if you remember from previous, when we say the word or, we add. I can break them into a group of 5 and 3. So take the 8 students, choose 5 of them, and then I have to choose the last 3 of them, right? So C of n comma n is always going to be 1. If you're choosing all the people, there's only one way to do it, right? So I want to do C of 8 comma 4 and C of 8 comma 5. So combination 8 comma 4, combination 8 comma 4, and then I want to do combination 8 comma 5. So if I'm going to put 4 in one car, there are 70 possibilities times 1. Plus, if I put 5 in one car, there are 56 possibilities times 1. I have to put all the other 4 in the other car. So this is 70 plus 56, 126 possible groups they can make. And this is the 2 possibilities of 4 students in both cars, or 5 students in one and 3 in the other. I have to take all 8 students, right? So I can't do any less than 4 in a car. I can't do any less than 4 and 4 or 5 and 3. Can't put 2 and 6 because the cars don't hold enough people. Okay, so what do I do if I'm going to mix together permutations and combinations? So let's sort of think about why this problem mixes them together. How many words of 4 consonants and 3 vowels can be made from 12 consonants and 4 vowels if all the letters are different? So what do I have to do in this problem? I have to choose the 4 consonants, and I have to choose the 3 vowels, and I have to arrange the 7 letters I chose. So here I'm just choosing 4 consonants and 3 vowels. These are both combinations. And then I'm going to arrange the 7 letters. This is going to be a permutation. So what I'm going to do is I'm going to choose the 4 consonants out of 12, and when you say that word and, you multiply. I'm going to choose the 3 vowels out of 4, and I'm going to arrange, permute, the 7 letters that I chose. So I'm going to put this in Desmos to get this number. You could write down the formulas if you want to. 12 factorial over 8 factorial times 4 factorial. 4 factorial over 1 factorial times 3 factorial. And this is just going to be 7 factorial over 0 factorial, which is 1. But you can just put it in Desmos. So first I'm going to combination 12 choose 4 times, then I'm going to combination 4 choose 3 times, then I'm going to permute those 7 letters that I chose. So 9,979,200. 9,979,200 possible words. And we use that word words lightly because they might not all actually be words in the English language. So I want you to think about breaking down your problems into ands and ors, determining if each part is a permutation or a combination, and then how do you combine them together.